not go over that fake practice test you just took, okay? So let's start. So the first question, and it's pretty much going to look like this, okay? And let's start with that question. So order of operations, and I'm going to, hopefully I can write it over here. 14, let me pick a different color. 14 minus 10 to the third power minus 15 divided by 3 to the second power. So remember order of operations, right? Or division, addition, or subtraction. So we have to do inside the groupings, right? The parentheses first. So remember that 3 is outside and that 2 is outside. So all I'm going to do is 14 minus 10. 14 minus 10 is 4, and then to the third power. I'm not going to do that now. Minus, and over here I have 15 divided by 3, which is 5. I'll leave it inside the parentheses, and then to the second power. So all my grouping is done. Now I check for exponents. Do we have exponents? Yeah, we do. So 4 to the third power is, hopefully you have a calculator, 4 times 4 times 4, and that's 64. Minus, and here this exponent is 5 to the second power, and 5 to the second power is 5 times 5. 25. So if you subtract these two, 64 minus 25, you should get 39. So the first answer, question, the answer was D, 39. 2, what's the prime factorization of 72? So one of the quick ways you can do this, you can either do it yourself over here, or you can multiply. Take your calculator and multiply. Well, actually, I take that back. Because prime factorization, remember, all the numbers should be prime. So is 2 a prime? Yes. Is 2 a prime? Yes. Is 8 a prime? No. So this one, for example, doesn't, you don't even have to consider. The other ones, all of them are prime numbers, right? So it's just a matter of seeing which one multiplies to 72. So I guess one way you can do this is just take the calculator and multiply 2 times 2 times 2 times 3 times 3. See if you get to 72. Or see letter B, 2 times 2 times 2 times 3. See if we get to 72. Or even the last one, 2 times 2 times 3 times 3 times 3. See if it gets to 72. So I'm actually going to do this because it's good practice. So 72, 8 and 9. 9 is 3 and 3. They're both prime numbers, so I circle and I circle. 8 is 2 and 4. 2 I circle. 4 I can break up into 2 and 2. So now I'm finished. So 72 is 2. Times 2, times 2, times 3, times 3, right? There's 1, 2, 3 2's, and 2 3's. Is there any of these that look the same as this? And that would be that one, letter A. Okay? Remember, you can also write this in exponential form. So this would be 2 to the third power times 3 to the second power, because there's 2 2's. 3, what's the prime factorization of 2,400? Yikes. So again, I would break this up. So remember the little trick with zeros, right? When the zeros at the end. So if that was 240, we could break that up into 24 and 10 because there's 1 0 there. Now because there's 2 zeros here, one number should be 100 and the other one should be 24. Okay, so that's a nice little trick that we can use. So 24, let's pick 2 and 12. 2 I circle, 12 I can continue, 12 is 2 and 6, 2 I circle, and the 6 will be 2 and 3. Circle, circle, because they're prime numbers. The 100 becomes, I don't know, 2 and 50, that's fine. Let me change color so you can see. 2 and 50, 2 I circle. 50 could be 5 and 10, 5 a circle, and 10 will be 2 and 5, and then I can circle and circle. This one's a long one. It's how many 2's? 1, 2, 3, 4, 5 2's. So it's 2 times 2 times 2 times 2 times 2, 5 times, and then there is a 3 over here, and then 2 5's. But notice that our multiple choice in exponential form, so let's change our answer we just found in exponential form. There is 5 2, so I can write that as 2 to the 5th power times 3, right? There's only one 3, so that stays. And then how many 5's? There's 2 5's, so I can write 5 to the 2nd power. Is there any answer that looks like that? Yeah, right here, letter C. Okay. Let's scroll down. So careful here is number 4. pencils comes in packages of 8, and erasers comes in packages of 10. So we did a problem like this, I believe, today. This is pencils. There's 8, and I'll write pencils. And then erasers have 10. So now imagine that I'm going to buy a pack of each. I'm going to have more erasers, so I don't like that. I like to have the same amount. So how many more packs do I have so that they end up being, so I have the same amount of pencils and erasers. So this is an LCM problem. Let's do that. 8 and 10. 2 works 4 times. 2 into 10 is 5. No number goes into 2 and into 4 and 5, so we're done. So we circle. So the LCM is 2 times 4 times 5. 2 times 4 is 8. 8 times 5 is 40. So I need to buy 40 pencils and 40 erasers. So let's think about this. I need to buy 40 pencils. Well, each pack of pencils have 8, right? So I'm going to divide 40 divided by 8. So let me just do pencils. And that means I need 5 packs. For the erasers, right, I need 40 erasers, and how many erasers in each pack? 10. So 40 divided by 10 means I need to buy 5 packs of erasers. So is there an answer that says 5 packs of pencils and 4 erasers? Yes, there is, right here, letter B. 5 packs of pencils and 4 packs of erasers. Okay? So far you should be really good. What's the GCF at 30 and 48? Okay, that's very easy. Think of a number, 6. 6 goes into 35 times. 6 goes to 48 8 times. Can we continue? No. So GCF, remember, is only that number. And right here. What is the LCM of 12 and 18? Remember LCM? That's 2. 2 goes into 12 6 times. 2 goes into 18 9 times. Can we use another number? Yeah, we can use 3. 3 goes to 6 2 times, and 3 goes into 9 3 times. Can we continue again? Nope. So the LCM, right, is all those four numbers multiplied. 2 times 3, 6. And again, multiplied by another 6, right? Because that 2 times 3 is also 6. So 6 times 6, 36. So our answer is D. Okay. 7, another LCM problem. Gee. So LCM of 8 and 12. Let's pick a number 4. 4 goes into 8 2 times. 4 goes into 12 3 times. We can circle, right? Because that's LCM. Remember, make the letter L, so that should remind you of the LCM. So the LCM is 4 times 2 times 3, and that equals 24. Right here. All right, so I'm gonna do. Let me show you listing all the multiples. So the multiples of 8, 16, 24, 32, 40, etc. Right? 12 would be 12 times 1, 12 times 2 is 24, 12 times 3 is 36. So right away there, right? The first number that shows up is 24. So whether you do it the listing way or you do it with the ladder method, you get the same answer. 8, GCF of 40 and 32. Now, you know what, just instead of the ladder method, let's list all the factors. 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, 5 and 8. 32. So 32 is 1 and 32, 2 and 16, 3 doesn't work, 4 and 8, 5 no, 6 no, 7 no, 8 is already. So what do they share? They share the 1s, right? The 2s, the 4th, and the 8. So the common, remember how we did this? They have in common the 1, the 2, the 4, and the 8. Which one is the greatest common factor? Which one is the greatest common factor that they share? And that would be 8. Okay, but you could have also done the ladder method. Okay, which, you know what, just so what number goes into 40 and 32? Well, let's use, you can use 2, you can use 4, you can also use 8. 8 goes into 45 times. 8 goes in 32 4 times. Can we continue? No. So we want GCF. So remember, GCF is only that number. GCF is 8. So either way you do it, you get the same answer. Next one, I'm sorry, is a GCF of 32, 24, and 16. Okay, so let me just move this a little bit. 32, 24, oh, this one right there. All right, so think of a number. Can we use 2? Yeah, but I always like, if you can use higher, use higher. Can we use 3? No. Can we use 4? Can you, well, you know what? Let's go higher. 5. No, it's 4. I think 4 is it. 4 goes in 32 8 times. 4 goes 24. Oops, I messed up. 4 goes 24 6 times, and 4 goes 16 4 times. Can we go on? Yes, we can. But your teacher messed up. 2 goes into 8 4 times. 2 goes into 6 3 times, and 2 goes into 4 2 times. This is GCF. Although you can say, but we can continue with 4 and 2. Yes, if this was LCM, but GCF, it has to go all 3 numbers, right? So we have to find a number that goes into 4, 3, and 2. And the only number that works is 1, and since it's 1, we know we're finished. So the GCF is 4 times 2, which is 8. 7 to the 5th power. How do we use that? Using repeated multiplication. So 7 to the 5th power is 7 times 7 times 7 times 7 times 7. Do you see any of that there? Yeah, looks like letter C, right? That was a silly question. Rewrite 2 times 2 times 2 times 3 times 5 times 5 times 5 using exponential form. Okay, so let's look at that. So it's, first of all, let's do the 2's. There's 2 times 2 times 2, so that's 2 to the 3rd power. The 3, there's only one 3, so I just write 3. And then 5 to, there's 1, 2, 3, 4, so it's 5 to the 4th power. Do we have a multiple choice that looks like that? Yes, we do, and I think that looks like letter A. 12, a square, so again, think of this, square, okay, has side that's measure size. So if it's a square, I know that this side is 5, that's 5, right? So how do we find the area? To find the area, we multiply this side times that side, and it's 5 times 5, which is 25. Okay, that basically means that's whatever unit this is. 1, 2, 3, 1, 2, 3, 4, 5. How many little squares we have inside? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And that's why our answer is 25 units squared. Okay, and in this case, it's A. So over here, let me write this a little bigger. 5 to the 2nd power minus 2. Now I want you to write a little dot there. Times 8 minus 3. So let me write this. Is there a parentheses? Yes, there is a parenthesis. Let's take care of that first. So I copy this. Don't do anything. Copy this. Don't do anything. Don't do anything. And then 8 minus 3 is 5. Is there anything else I have to do in the parentheses? No. So that is gone. Exponents? Yes, there is. You can see it right here. 5 to the 2nd power is 5 times 5. So this I'm going to change to 25 minus 2 times, and you can take the parentheses out now. Just write 5. So exponents is gone. Now, do you see any multiplication or division? Yes, you should. So we're going to do this first, because that's multiplication, and that comes before subtraction. So 25, copy, minus, I copy, and what's 2 times 5? 10. Is all my multiplication or division gone? Yes. Now I can do the last thing, which is 25 minus 10, and that should give us 15, and none of these choices are correct. That's weird. That's okay. All right. So 13 should be, and you know what? 13, I'll make it C. Okay, 13, I'll make it C. So 13, C, 15, I'll change that. I'll change that later by the time you get this. Okay, 13 is going to be C. 14. So the bonus word, okay, it's going to be cyclone. Okay, cyclone. All right, so that gets you a nice 2 percentage points. Okay. So here's a question, and it says 924. If we do the prime factorization, it's going to be 2 times 2 times something times 3 times 11. What's the missing number here? There's a missing number here. And the only way to find out is probably to do the prime factorization. Okay, so 924, and you're going to have a calculator. All right, so, well, 2 works, right? So what you can do is take your calculator and divide 924 divided by 2, and you're going to get 462. Okay. So 2 we stop, 462 we can continue again. Well, it's an even number. Can we use 3? We can use 3 too. Let's use 3. I know it's used, I can divide by 3, so it's going to be 3 and something. So on my calculator, I'm going to put 462 divided by 3. And that's going to give me 154. The 3 I stop, but the 154 I can continue. 154 is an even number, so I know it's 2 and something. So if you on your calculator, you can put 154 divided by 2. It's going to give you 77. 2 I can circle, and 77 I can put 7 and 11. Well, 7 is a prime number, so I stop. 11 is a prime number, so I stop. So if I were to write this in order, it'd be 2 times 2 times 3 times 7 times 11. So compare this to this. Here I have a 2, I have a 2, I have another 2, and I have a 2. Do I have a 3? Yes, it's up here. Do I have an 11? Yes, it's up here. So the missing number that's not on top here would be the 7. Okay? And if the question here shows you to show work, ask you to show work, you would have to do that part. Okay? Where are we? Okay, 15. Nice, and this is not that bad. So Larry has 2 pieces of wood. Okay, so one piece measures 18. So imagine this measures 18. Here's 0, here's 18. And the other one measures a little bit longer, 18, 19, 20, 21, right there. All right, so he wants to cut the wood in equal pieces that are as long as possible. So what's the longest piece, most longest size piece that I can cut each of them? So every piece is the same size. Well, this is a least common, no, greatest common factor, sorry. As long as possible, right? So we want the greatest piece possible. So here's 18 and 21. And let's see, 3 works. 3 goes into 18 6 times. And then 3 goes into 21 7 times. Oops, 7 times. So the GCF is 3. So which means that in the 18 I can cut it into 6 pieces. I'm going to have, this is going to be 3, 3, 3, 3, 3, and 3. Notice I have 1, 2, 3, 4, 5, 6 pieces. And the 21, I'm going to have 7 pieces. 1, 2, 3, 4, 5, 6, 7. So 3, 3, 3, 3, 3, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And that last one is 3. That's just drawing just a little bit too big. But that 3 is the only, it's the highest number that works in both pieces of wood. Okay, I wouldn't be able to use 4 or 5 or 6. So 3 is the greatest. It's as long as possible that I can cut. Okay. Six. Sorry. Leela wants to place 36 M&M and 88 Skittles in goodie bags. Each bag should contain the same number of pieces of candy. What's the greatest possible number of pieces of candy in each bag? Okay, how many M&Ms and how many Skittles will each bag have? Okay, so this is a GCF problem. Let's use a number 6. 6 goes to 36 6 times. 6 going to 48 8 times. Oops, we can go again. Use 2. 2 goes into 6 3 times. 2 goes into 8 4 times. So here's my GCF. So GCF is 2 times 6 or 12. So how many goodie bags can she make? That's that. What is the number of pieces of candies in each bag? So each bag, well, so you're going to make 12 goodie bags, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this bag, what is this? 36 is M&Ms. This is Skittles. So each bag is going to have 3 M&Ms and 4 Skittles. 3 M&Ms, 4 Skittles. 3 M&Ms, 4 Skittles. So how many candies will each bag have? Each bag will have 7 candies. Okay, it's going to be 3 M&Ms and 4 Skittles in each bag. Okay. Where are we? 17? Yeah. Okay, 17. At something at 8:30 a.m. Can I make a little bit more room? Sorry. Okay. So 17 says there's a show that starts at 8:30 at I think we did this in class. Well, anyways, National Capitol, tours of the National Capitol and the White House begin at a tour agency at 8:30. The National is every 15 minutes. The White House is every 20 minutes. Okay, so they both start at 8:30. So one would start at 8:30, right? They both start at 8:30. So the next one would be at 8:45 for the National, and for the White House would be at 8:50, and so on and so on. So, but at what time would they have a tour, the same tour, starting at the same time? So this is an LCM problem, right? So we can go 5. 5 goes into 15 3 times. 5 goes into 24 times. LCM is 5 times 3 times 4, and 3 times 4 is 12, 60 minutes. Really? No, it doesn't make sense. Even the 5 goes 53 times. 5 times 4 is 20. 20 times 3 is 60. Yeah, all right. That makes sense. So in 60 minutes, they will have a, what do you call, a tour at the same time. And just to show you, okay, that is the correct answer, it says 60 minutes, right? So if they both start at 8:30, right? The National, the next show would be at 8:45 because that's 15 minutes later. 15 minutes later after that would be 9 o'clock, and then 9:15, and then 9:30, right? 9:45. So that's the National tour. The White House is every 20 minutes. So 8:30 plus 20 minutes is 8:50. 8:50 plus 20 minutes would give you 9:10. And 9:10 plus 20 minutes would put us at 9:30. So you can see that at 9:30, they have a tour. They have both tours starting at the same time. Okay. And finally, we have our last question for the evening, ladies and gentlemen. Your friend found the GCF two numbers. Do you agree or disagree with his work? Well, let's check his work. So let's do ours at the same time and we compare side by side. So he chose 2. So let's start with 2. So 2 goes into 20 10 times. 2 goes into 50 25 times. So far, so good. And then he chose 2 again. Oh, I don't know why he did that because 2 doesn't go into 10. 2 goes into 10. 2 doesn't go into 25. So I don't know why he put this 2 here. So I am going to question. There's something wrong there. So if we do it, right? So the next number should not be a 2, but it should be a 5. 5 goes into 10 2 times, and 5 goes to 25 5 times. We want the GCF, which is these two numbers. The GCF of 2 and 5 of 20 and 50 is 2 times 5, and the GCF is 10. Okay, so if this was your test question, well, right, real, you would have to write and explain all this. That I don't know why he put in this instead of a 2, should it be a 5? And then when you multiply, instead of the GCF being a 4, it should be 2 times 5 and 10. So you would have to explain all that. Okay, so your test is not too much different than this. Okay, of course, it's not going to be the same exact questions, but if you do well on this, you should be really, really okay. All right. So